Hi guys, welcome to my channel. In this video we are going to solve the questions about the study course, and the question will be how to draw shear and the moment diagrams. So let's draw the free body diagram of the shape. And for example, this one is the triangular distributed load. Sorry. And I have an AY, I have an AX, and I have a BY because this is roller, and I have a moment here, 300 pound-feet, and I have a 150 pound-feet as the force here, but it's going to apply it as 150 multiplied 12, okay, and over 2, and it's going to apply it, for example, at this point, okay. So for this one, let's write the moment equations. For the moment at A, I need to determine the the reaction forces. Okay, for the reaction forces, it's going to be minus 1.50 multiplied 12 over 2 and multiplied 8, because look at here. This is going to apply it at 8 and it's going to be 4 meters, because the center of gravity for the triangular at the 2/3 of that. 2/3, okay? So this is, for example, 2x, this is 3x. So if 3x equal to 12, 2x equal to 8, right? So this is going to be 8. And also we have minus 300 multiplied, sorry. We just have a moment, not multiplied. We don't, it's not a force to take into multiplication. So this is moment 300, and we have as by, okay, by multiplied 12 equal to 0, and by is equal to 625 pounds. So now we have by, and from the total Fy equation, total Fy is equal to 0. It's going to be 150 multiplied 12 over 2 minus 625 minus ay equal to 0, and ay from this equation I'm going to obtain 275 pounds. So now we determine the ay and by. We already know that ax is equal to 0 because there is no horizontal force, okay. So now we have the both shears. So let's try to show you how the shear diagram is going to be seen, and then I'm going to try to calculate the maximum, local maximum and the minimum points for the diagrams, okay. So now I have a 2 point. So for example, this is point A, this is point B, and A and B. I have AY as equal to 275 pound. So 275 pound, 275, and this is shear. Sorry, this is moment. So this is a triangular load. Now you can see, okay, this is a triangular load. So for the small part, this is the small part, this is the big part. So the triangular load is a little complicated, but it is easy. So just watch and what I say and what I do, okay. It's going to be decreased as a parabolic, but it's going to decrease at a small portion when it reaches to that point, because when it goes at this direction, the force applied much more, right? When you goes at this direction again, when you continue to go at this direction, it's going to be applied as force as much more. Look at here, much more, and then it's going to reach to this point, and this point is 625. Okay, this point. Now we have the shear diagram, but we need to determine that point, okay, that point. And the moment diagram, it's going to be something like that. We are going to start with 0, And for example, this is the point where for example, this is x, this is the point where it's x, and it's going to get down and reach, for example, no, sorry, I have to take a tutorial about the drawing. This is going to be the point 300 as moment, okay, because it's going to reach to 300. Why? This support is a roller. So if it is a roller, so that means that there is no moment here. Normally it should start at 0, okay? If there is no any moment here, it should start, so it should stop at 0. But now we have a 300 pound-feet as the moment here, so it's going to go down and reach the 300 pound-feet for this moment that applied to the clockwise direction. Okay, so now we are going to determine this maximum moment and this point where the local minimum and maximum and the heel to change. This is positive, this is negative. Okay, so let's try to find it. Yeah, for example, we have a force like that, right? For example, this is our beam and we have a force 150 pound, yeah, pound to feet. And for example, this is point where x, okay, where x, and this is gx, force, okay? And this whole length is, what is the whole length? Is 12, right? 12 feet. So I'm going to write a function and we are going to determine from that. So gx, for example, equal to x, right? And 150 also equal to 12. When I take this multiplication, gx, it's going to be equal to 12.5x. Now we obtain the gx, so let's write the gx its own place. And I'm going to take this part, okay, this part to here. Look at here, what I'm going to do. For example, I take just this part, okay? So it's going to be something like this. This is 12.5x, okay? This is gx. Gx equal to 12.5x. So, and I have a length here. The length, what is the length? Length is x. And I have a force as a shear force. What is that much shear force? It's point A, right? This is point A. Sorry, this is point X, for example. And what is the shear force here? Here, 275 pound. I have a shear force. So, if I have a shear force here, I will have a shear force as downward direction. And also I am going to have a moment, okay, moment at this direction. Now I guess you understand what I'm going to do. So now I'm going to write as total Fy is equal to 0, and it's going to be shear, here you can see, plus 12.5x multiplied x over 2. Okay, so because it's a triangular, and minus 275 equal to 0, and shear will be equal to 275 minus 12.5 x squared over 2. Now we obtain the shear equation, how to determine the point where the shear is 0. When I write into this equation, instead of v as 0, okay, so 0 equal to 275 minus 12.5 x squared over 2, and I'm going to obtain as x equal to 6.63 feet. Okay, now we obtain the point where the shear force is 0, this point, okay? We obtain x. So let's determine the maximum moment. Look at here, at this point, the moment at the maximum value. So now we have to determine that point. So let's find it. So I'm going to write the total moment respect to x equal to 0. And it's going to be minus 275 multiplied x and plus 12.5x multiplied x over 2 and multiplied x over 3. Look at here. This is a triangular, so it's going to be 2x over 3, this length, the point of which the point load will be applied. Okay, so this is going to be 12.5 x squared over 2, and it's going to be applied to this length. This is going to be the moment arm, and this is x over 3. Okay, so this comes from there. So now it's okay, and I'm going to take the moment equal to 0, and the moment is going to be equal to 275. Okay, and minus 12.5 x cubic over 12, and this is the equation of the moment. So now let's write the x value into the equation and obtain the moment equal to 1216 pound feet. This is going to be the maximum. Okay, this is going to be the maximum point of this moment. Now we obtain the shear and the moment diagram. You learned how to draw the shear and the moment diagram. And for the triangular distributed load, I guess you understand how we are going to try to find the point of the shear force when it gets 0. Okay, so now the question is solved. If you like these videos, if you want to see more of the videos, please subscribe and share with your friends. If I did anything wrong, please comment. I am going to try to fix it. So see you for the next question.